Yes, question. Are we going to have a lot of time to work on homework today? I think so, actually. I mean, there's a good chance. There's a good chance. I'm hoping. I don't really have the timing worked out quite, for this, but it's quite possible. In my estimation, yes. Yeah. Okay. And I like giving you guys time to work on homework too. Don't like, I I don't like having to talk, for as much as I do sometimes, but we just have a lot of material we got to cover, and I don't know how else to deliver it to you besides the way I'm doing it right now. So anyway, here we go. So today we're going to be talking about inverse functions. Okay, this is still within that section 3.6. It's actually kind of like the main, well, not the main topic. It was if you looked in the book, it's actually the first topic that they cover in the book in section 3.6. And then they go into inverse trig, but this, we just did it out of order, so it's no big deal, okay? So we're going to talk about inverse functions, but also the derivative of inverse functions kind of in general, right? Yesterday we talked about specific inverses, the trig inverses, and learned their rules. But now we're going to talk about kind of just more a general kind of what happens when you take the derivative of an inverse and stuff. But first, we're going to refresh our memory about what an inverse is. So given a function here, an easy, simple function, like a set of ordered pairs, all right? In order to come up with the inverse of that function, what needs to be done? Do we remember? What's that, Bryce, did you say? So we sometimes could use the original equation and you like swap the x and y's, right, and then solve for it. So that's one thing here. But if we have just a set of ordered pairs, all we need to do is just swap the x and y's, and that results in the inverse of the original function. Oops, and I just made a mistake there because I'm reading it. Okay, I'm talking. So yeah, so 1, 4, its inverse point would be 4, 1. Right? The inverse of 2, 5 would be the point 5, 2. 3, 6 will become, did it again, 6, 3. Okay, and 4, 7 becomes 7, 4. There we go. Okay, so there would be the inverse function, something that shouldn't be as hard as I made it, but there it is. Graphically speaking, do you remember what kind of transformation, if you have your original function and you want to find its inverse, what kind of transformation can you do graphically? Do you remember what it is? What to do? Yeah, Simeon? There you go. Flip it over the line y equals x. Exactly right. So if you have a function and you want to kind of graphically come up with its inverse, you can also take your original function, reflect it over the line y equals x, and that will result in then your inverse function's graph, okay? Which then maybe makes sense why a function, to find its inverse points, right? Well, if y is equal to x, then we're just going to switch the y's and the x's, right? Y becomes x, x becomes the y. They swap around like that. Okay. That's kind of the idea there. Okay. If you remember that from geometry, I don't know if you guys remember the coordinate notation for reflecting over the line y equals x, but it was that right there. Okay. Oops, I'm off the screen. There we go. xy becomes yx. Hello? Hi. Sure can. Mm-hmm. Bye. Gabe, they want you in the AP office. All right. So, that was the coordinate notation. Oh, you guys remember that from geometry? I know that was years ago. Okay, and maybe geometry gave you nightmares or something like that. I love geometry, but I'm a math teacher, so I guess that doesn't surprise you. Anyway, definition of inverse function. So, a function g is the inverse of the function f if f of g of x is equal to x for every x that's in the domain of g, and g of f of x equals x for every x in the domain of f. So you need to have both of these things to be true in order to say that g is the inverse function of f. So in other words, if you plug g into f, you should be able to simplify it down to just x. And if you plug f into g, you should also be able to simplify it down just to x. Okay? Both are required to say that g is an inverse function of f. Okay? So you wouldn't just plug g into f and get x and say, okay, I'm done. That shows it's an inverse. No, you have to do both. Okay? So let's show here that the functions are inverses of each other. So, why don't you guys go ahead and do that? So go ahead and find f of g of x and also do g of f of x here. Okay? Give it a shot. Okay. So go ahead and give it a shot there. Try it out for yourself. Okay, use composition of functions. Okay, so hopefully we came up with x and x. All right, so there are our two. All right, so we all good with that? Yes, yes. Even if you didn't come up with x, you're like, oh, now I see. Okay, so they do both give us x there. Okay. So of course, we not only should be able to verify inverses, right? That's something from, way back when. We also, know how to find the inverse. I think, Bryce, you were kind of hinting at how we find the inverse, right? So f of x, we can change that to just y equals the square root of 2x minus 3. And then what do we do from this point to then find the inverse of this function? Swap x with y, okay, with their locations. And then what? Solve for y, right? So we'll square both sides, get x squared equals 2y minus 3. And so we get x squared plus 3 equals 2y. All right, and then we'll divide through by 2. So you could say, y equals x squared plus 3 all over 2 if you wanted to, right? Because we're dividing both sides by 2 there. Or you could then break it up and make it 1/2 x squared plus 3 halves. Okay? Now, let's go ahead and take a look. I'm going to show you this graphically. You don't need to type this in your calculator if you don't want to. You can just follow along here with what I'm doing on the screen. Okay? But I'm going to go ahead and graph the original function there, square root of 2x minus 3. All right, and then also show you 1/2 x squared. Whoops, doing the wrong thing here. 0.5 x squared plus 3 halves. Okay? So zoom 6 there. All right, there's the one, there's the other, and I'll show the line y equals x as well, so you can kind of get a visual, of the whole reflection. I think actually I do zoom square. There we go. So you can see the reflection there. Ooh, but we have a problem, don't we? Okay, is our original function, if we reflect that over the line y equals x, will that be its image? Not quite, right? Right, because in our original function here, we're missing the kind of bottom piece as well to then, if we reflect over the line y equals x, to get that full graph right there. So when we talk about the inverse here of this function, since we're only talking about positive square root of 2x minus 3, which is just this positive piece of the square root there, we then need to restrict the domain here of this to be able to correctly and accurately describe the what the inverse of this would be. And so for this situation, All right. What x values do we only want to count? Anything greater than 0, right? X values greater than or equal to 0 will result in just this. In fact, let me just show you here. I can do that, right? If you remember from our piecewise graphing, if we take that function and divide by x greater than or equal to 0, okay, now we'll go and graph it, and it should only graph for x values greater than or equal to 0, and voila. Okay, so now we can see a good reflection there. Yeah, show me.
What if it's the opposite? Like, what if the regular function is further out and then you have to do the inverse?
So good question. So let me show you then what that would be. So you're saying if we started with this and we were asked to come up with the inverse of it. Okay, so good question. So 1/2 x squared plus 3/2 equals y. Okay, we go through the normal procedure here, swap the x and y's like we did before, right? So permit me to take that step. Okay, subtract 3/2 from both sides. So again, we'll just solve for y. I'll go ahead and just multiply through by 2. So far, so good, right, everyone? Okay. So then square root both sides. Since we are taking the so in this situation right here, I have not restricted the domain, right? So we're talking about the whole quadratic here. And so when I go down to here, when I take the square root of both sides in an equation setting, we'd want to put the plus or minus in front of it, square root 2x minus 3, and then that would result in the full kind of, graph there. Of course, the problem is now we're talking about something that's no longer a function as well, so that can kind of cause a little bit of issue, but yeah, that should be it. So does that make sense?
Yeah.
Okay. And so again, just for those of you that are curious, right? So if we were to graph this, so let me get rid of the restriction that we made. I have the positive root 2x minus 3. I'll also put the negative 2x minus 3 in there, so you can get plus and minus. I'm not sure. I don't think there is a plus or minus command. I don't think so. I think we just have to graph the positive version, graph the negative. Yeah, I think we just have to graph the positive version, graph the negative version. So we'll do that here. And of course, it's going to graph it out of order because of the way I did it. But there you go. All right. And so it should look like a reflection there. Of course, we have like maybe more of the y-axis there. I think I did zoom square though, didn't I? Anyway, so you can see there's the reflection of it. Okay. And it would look right. Yep. Okay. So there's that. All right. So you just want to be mindful of what you're graphing, and then the graph too, and restrict things if necessary. All right. But let's get into the actual calculus here, right? Because that's all review, really. So turn the page there, and we're going to talk about the derivative of an inverse function investigation. So here we've got two functions. We've got f of x equals x squared, and we're only going to consider x squared for x values greater than or equal to 0. And we've got g of x, which is equal to the square root of x. Okay? So I think I would like you guys to go ahead and try this out, I think. See how far you can get with it, because it is an investigation. So I want you guys to kind of have the opportunity to wrestle with it a little bit on your own before I swoop in and just explain it all away. Okay? So go ahead and verify the two functions are inverses. Okay? Then I want you to write an ordered pair for the function f at x equals 3. So in other words, I give you the x coordinate, come up with a matching y coordinate, and then determine that matching inverse point on g of x. So for example, you'll have 3 comma blank for f. What will be the matching inverse point, or the corresponding inverse point in g, if it's the inverse, right? And then you've got some work to do here. Keep in mind, I want to be careful here. This is f inverse. There's supposed to be a prime there. It's kind of hard to see. And then same thing here, f inverse, and there's supposed to be a prime there too. It's kind of hard to see. So I'm going to make it more obvious that there are primes there. Okay? And so just go ahead and do 1 through 6. Go ahead and do 1 through 6 there. Give those a try. Okay? And I'll come around and kind of help guide you as necessary if you're like not clear on what the directions are asking you to do. Okay. And for number 4, you may absolutely use your calculator to determine the slope at those specific ordered pairs if you want to. Of course, it might be just as easy to do it mentally in some cases, but it's up to you what you want to do there. Okay. But number 4, you're asked to find f prime of 3, and number 4, you're asked to find g prime of 9. Okay. Okay. Nice shirt.
I don't want to get confused, what to do. I mean, I think I understand what to do for this one.
F prime of 3. So what does that mean?
So I'm just going to take the slope of, what's up through?
So yeah, so derivative of f at 3. Right.
This one, kind of threw me off this, I think.
So saying g prime of 9. Saying g prime of 9. G, if you remember, we defined up here, we said it's the inverse of f.
Right.
So saying g prime of 9 is equivalent, the same thing as saying f inverse prime of 9, right? Because g is f inverse. So saying g prime of 9 is the same thing as saying f inverse prime of 9.
Okay.
That's all. So you can think of it this way, or you can just think of it this way too, but then find that value. What would g prime of 9 be?
Okay, so, yeah.
Okay, I really didn't know. Oh, yeah, okay. 4 and 3.
Take derivative of that,
I don't know about that one. How do I do that? How do I derive a calculator again?
So graph it. And then second, trace. Do some calculate things. And then you know what you meant here. It's done here. Which one looks like derivative? There you go. And then type in your x value where you want to punch it. That's one option. So don't worry so much about this piece right here. You know what you want, right? If you find that, right?
Oh, yeah, sort of.
All right, like 30 more seconds here, or 30 seconds more, one more minute.
Reminder, don't do anything that requires calculating errors.
Will that be a long time
Say what now?
before we cover integrals?
We have, I think, one more unit, and then we'll get into integrals.
Sweet.
Yes.
Prolong it as much as you can.
Who warned you about integrals?
AP Physics.
Oh, yeah?
Because we're generally not allowed to learn about air resistance until you cover it.
Oh, gotcha. Yeah, it'll be a little while still. Let me see. No, we start integrals in Calc 1. Oh, yeah. Oh, yeah. It'll be in Calc 2, too. 2, too. But, it'll be like the unit after this year. It's fun.
I heard they're not fun at all.
Integration is weird because, like, derivatives follow like the typical kind of math thing that we have you do, where it's like we give you a problem and then you just solve it, and you get the answer, right? Whereas integration is like, here's the answer, come up with the problem that arrives at that thing. Okay, it's like and integration is backwards differentiation. You go backwards, okay, and it makes it a little bit trickier that way, but not that awful, but it's a little bit trickier. And then the problem becomes, well, now there's two possible answers you give Mr. Widmeyer. Are we supposed to take the derivative, or are we supposed to integrate it? Right now, anytime I ask you, what are we supposed to do? You say, take the derivative. But now, after integration, it'll be, well, it could be two answers. So now you have to make a choice. You can't just automatically say, take the derivative, right? So, got a 50-50 shot. That's right. So here's, there are your answers right there. Okay. Remember, if you want to evaluate the derivative of a function at a specific point, your calculator can do that for you, right? We've been doing it all on our own up to, for the most part. We don't really use our calculators, but I want to keep that in mind because, on the calculator section, you absolutely are expected to use your calculator. Even if you could do it by hand, use your calculator because it's just going to save you on time too, right? So just to refresh your memories a little bit here, if we wanted to find, for example, f prime of 3, we have two options available to us on our graphing calculators. Option 1 is to graph f, okay, and your y equals, and then go to second trace, which is the calculate menu, and go down to the dy dx command there. Oops, it's in black and white. There we go. Okay. So I got to wait for it to graph. Oh my gosh. All right, hang on. So then 3, and then there's the derivative. Hello? Hi. Gotcha. Gotcha. Sounds good. Bye. Emily, you have a pass from Miss Byrne.
I already got it.
Right. So she said that you were supposed to wait till after the drill to go. There's a drill at the beginning of second block. It's going to be like a drop and cover drill. So you are supposed to get on the ground and put your arm over your head or something like this. It's under the desk. I don't know. They said put your arm over your head. So I don't know what that means. So for a minute you have to sit like this. Okay. Okay. How I did what? Yes. Second trace. Go down to dy dx. And then you can hit enter if you want to just pick a random point. But if you type in the x value 3, and then hit enter, dy dx equals 6. Shh, I'll come to that. One sec. So did you type in your function accurately? X squared? And dy dx, and you typed in 3, and you hit enter. All right, real quick here. Hold on. Oh, y. It was y coordinate this time, and you see dy dx there. Type it again, you'll see dy dx there. Okay, moving on here. Now, question. Okay, so Morgan, you asked how to get this. So you can do it one of two. So g prime, right? So these two things are equivalent. That's all this is trying to show you here. The g prime, all right, of 9, which again you can just do the the square root. So square root of x. Okay, second trace, dy dx, and we want to find g prime of 9. And so we get 0.16666666666 forever. So that's 1/6. What'd I do? All right, so 1/6. There it is. What's the matter? I'm seriously don't understand. Because I said a bunch of 6s in a row? Okay. All right. So anyway, so that's where it comes from. All right, 1/6. The importance here is that G, right? To understand here is that G is the same as F inverse. So when I write G prime here, that's equivalent to saying F inverse prime at 9. Okay. Now why do we pick 9? Well, if you remember that 3, right, was the x coordinate of our point, but then the corresponding x coordinate in the inverse would be 9, right? 3, 9 was the point we had in F. 9, 3 was the point we had in G. So evaluating F prime at 3, evaluating G prime at 9, we see a relationship between their slopes, right? Same thing here. Evaluating F prime at 2, all right, and then evaluating F inverse prime at 4, we get 1/4 and 4, okay? Which again, F at 2 is the point 2, 4, and then G, that point would be 4, 2, okay, for G. And so we can see here that it seems that there is a relationship when we evaluate the function, the derivative of the function at a specific x value, and evaluate the derivative of the inverse of a function at the, kind of like inverse point, the slopes, the derivatives are related, okay? And in fact, how does it look like these derivatives are related? They are reciprocals, right? They're reciprocals of one another, okay? And so it looks like, so however you want to specify that there, it's up to you. I'm not even sure what I would want to write there. But more importantly is this formula down here at the bottom, okay? The derivative of an inverse function. This leads into nothing, okay? But it is a common question that is asked on the AP test. As I said, it's typically multiple choice. It's typically non-calculator, but it could be calculator, okay? And it's just basically like, the question is basically, did you memorize the formula? And do you understand what the formula is asking you to do, okay? So that's why we have to teach it, because I don't want you to just miss out on a single point for something silly like this. So anyway, so the derivative of an inverse function, let f inverse be the inverse of f, a differentiable function. The derivative of f inverse at any point, x equals c, is this. So again, I want to kind of highlight this is f inverse prime there. The apostrophe doesn't show up real well there. But f inverse prime of c is equal to 1 over f prime of f inverse of c. Okay? The derivative of the inverse at c is equal to 1 over f prime of f inverse of c. Okay? And I'll show you how this is going to be done kind of in practice here, because I know looking at that you might be like, that's weird. But the primary thing, okay, you want to memorize this for sure. Have this memorized. Oh gosh. Okay? Memorize that formula. F inverse prime of c equals 1 over f prime of f inverse of c. And then we'll show you here how this works out in practice. Okay? So let's take a look at example 3 here so I can kind of show you how this works. Okay? So if you look here for letter A, we have f inverse of 3. That's going to be our first thing we want to answer. But then ultimately, we want to be able to find what is f inverse prime of 3. What is f inverse prime of 3? So going back to that formula, remember that if we want to find f inverse prime of value here, that's equal to 1 over f prime of f inverse of that value. Okay? So in this case, we're going to put a 3 in here, right? Ultimately, we're asking what is f inverse prime of 3, and so we're evaluating f inverse prime of 3 is what we ultimately want to evaluate here. So that's what I'm going to plug in the 3 in for the x there. So the first step here, A, is just merely us trying to figure out what is f inverse of 3, right? So we're figuring out what's inside that first. So what is f inverse of 3? So f inverse of 3 is going to equal some value, right? Some value like x, we'll say. Okay, it's going to equal some value x. Which again is kind of weird. We have f. How can we evaluate what f inverse of 3 would be? Well, same way we kind of do with inverse trig, right? if you remember from the way we I was showing you maybe an option evaluating inverse trig, when you have f inverse of something, set it equal to some variable, I said x here, and then let's just take f of both sides. So f of f inverse, well, those are inverses, so it'll just cancel out. And then f of x is that. So to find when what f inverse of 3 is equal to is equivalent to finding when does f of x equal 3. Right? Finding when f inverse of 3 is equal to is the same thing as finding f of x is equal. When is f of x equal to 3? So we just set our function there equal to 3. Okay. So, how we go about solving this little equation here? What should we do?
Add 5.
Not add 5.
Oh.
Because if we add 5, we're going to have to then start factoring out x's and stuff like that. But the problem is, if we start factoring x's, we're going to be equal to 5. Normally when we start factoring and set things equal, we want it to be equal to what? 0. So we'll subtract 3 from both sides, yeah. And then factor by grouping, exactly right. Yep. Okay? So yes, we have 4 terms there. Looks like it might be a candidate for factoring by grouping, so we'll group the first 2 together there. X squared can come out, leaving behind an x minus 2. In the second grouping, we can factor out a 4, and so we're left with another x minus 2. Thank goodness it factors by grouping, so we end up with 0 equals x minus 2 times x squared plus 4. Okay, one of the words, x equals 2, and x squared equals negative 4, which is imaginary, so we can throw those out. So what does f inverse of 3 equal? 2, okay? So what we essentially did here, right, is, well, I'll figure this out. So the x value here is 2. So in other words, f inverse of 3 is 2, okay? What we did here, right, is we knew that if 3 was the x value for our inverse, so it becomes the y value for our function, right? They swap places. 3 was the x value for our inverse, it becomes the y value. We found the matching x value there. And so then that x value for our function becomes the y value for the inverse, too. Okay. So now if we go back to our formula here, f inverse of 3, we have a value for that. It's 2. And so f inverse prime of 3 is going to equal 1 over f prime of f inverse of 3. But we know what f inverse of 3 is. It's 2, so it's really just 1 over f prime of 2. And these are the steps that we'll sometimes be taking in order to evaluate these kind of questions, right? First, you'll want to find what f inverse of that x value is. Then you'll evaluate f prime of that value. Okay? So, to find f prime of 2, what do we need to do? Take the derivative of f. So f prime of x, easiest derivative of my life. Whoops, and I made a mistake. That's what I get. Okay. 3x squared minus 4x plus 4. And so then plug in 2. All right, so 2 squared is 4 times 3 is 12, minus 8 plus 4. And so let's see, 12 minus 8 is 4, plus 4 is going to give us 8 there. Okay, so it's 1 over 8 is our answer there. Okay, 1 over 8. So you might be wondering to yourself, Mr. Blumeyer, why did we go through all of that work to figure this out, right? In the previous example, we had our function, we had our inverse. If I wanted to find if I wanted to find f inverse prime of 9 or f inverse prime of 4, I could just take the derivative of my inverse here and then plug in the 9 or the 4, right? I had my inverse. Well, my question to you, or is your question?
What is that saying?
Which one are you talking about? Sorry.
The 3x squared.
3x right here. That's my error that I made when I was talking real big like that. So it's just 3x squared minus 4x plus 4. If we go back to here, though, imagine trying to find the inverse of the function there on the screen now. Okay? Imagine trying to find the inverse of this. Making that equal to y, right? Changing that to y, and then swapping the x's and y's. You'd have like y cubed minus 2y squared plus 4y minus 5. And trying to solve for just y in this case, not quite possible, right? So this formula, and it's not that impressive, but it allows us to evaluate the derivative of an inverse without actually being able to come up with the inverse function itself. All right, we can kind of bypass actually finding the inverse function. Okay, so there it is. All right, so let's try it again here for another one, example 4. All right, we've got our function here, f of x equals sine of x for x values between 0 and pi over 2. Again, we have our intermediate step right here. We can see our final step. Our goal here is to do f inverse prime of 1/2. So in other words, using our formula here, we want to do f inverse prime of 1/2, which we know, according to that formula, on the other side is 1 over f prime of f inverse of 1/2, like so. Okay, and so again, these two steps here, we're just kind of breaking this up into 2 steps. We're going to first evaluate f inverse of 1/2, and then find f prime, whatever that value is. Okay, so f inverse of 1/2. Well, it's going to equal some value here. We'll say x. In other words, 1/2 is equal to f of x. Okay. What's our function? Sine. So, for this interval, when does sine of x equal 1/2? For the interval from 0 to pi over 2, so that's your first quadrant there, when does sine of x equal 1/2? Pi over 6. Okay, so so f inverse of 1/2 is pi over 6. Okay. All right. So then, when we go to do f inverse prime of 1/2, it's equal to 1 over f prime of f inverse of 1/2. We know what f inverse of 1/2 is. It's pi over 6. Okay. And so then we have to take the derivative of f. So the derivative of sine is cosine, positive cosine. And we want to evaluate f prime of pi over 6. So f prime of pi over 6, what is cosine of pi over 6? Root 3 over 2. Okay. So you get 1 over the square root of 3 over 2, which of course fraction within a fraction, we'll change that to 2 over the square root of 3. And we don't need to rationalize that. Okay, so again, while this may not make a lot of sense, and again, I kind of see it. It's kind of like a one-off thing that we do here, but really having that formula down and just taking it piece by piece, evaluating what's inside there first, and then going to the outside. That's going to be helpful to you. Okay, now if we turn the page, we'll go to 2 AP questions. Okay, 2 AP questions. 2 AP questions. These are from actual AP tests or practice AP tests, but these are more the flavor of the kind of problem you can expect on your own AP test. Okay, so let's take a look at this first one here, and then maybe I'll have you guys try the second one. Okay. First one, example 5. Let f be a differentiable function such that f of 3 equals 15, f of 6 equals 3, f prime of 3 equals negative 8, and f prime of 6 equals negative 2. So the function g is differentiable, and g is the inverse of f, right? G is equal to f inverse of x for all x. What is the value of g prime of 3? Okay, so you'll notice here, this is unlike the previous problems that we just talked about. We're not actually given a function f. We're not actually given a function g, but we are told that g is the inverse of f. And if you look here, we're taking the derivative of g prime. So in other words, this is a derivative of an inverse problem. Okay? So this is how you're going to clue yourself in to what you're supposed to do here. You're going to see inverses mentioned, and you're going to see the derivative of an inverse mentioned. And so right away, your brain should automatically go to f inverse prime of x, the derivative of the inverse, is equal to 1 over f prime of f inverse of x. You should just spit that back out there, and then we'll worry about trying to fill in the pieces here. Okay. Instead of using F inverse, though, what are they using instead of F inverse? G. So another way you could write this, instead of F inverse prime, you could say G prime of X is equal to 1 over F prime of G of X. Notice I'm just replacing G wherever I had an F inverse. So F inverse is now G prime. F inverse prime is G prime. F inverse of X is just G of X there. Okay. So we're just manipulating that little formula slightly. And now we'll just go ahead and plug in the 3. G prime of 3 equals 1 over F prime of G of 3. Okay. Now, are we told anything about the values of G in this problem? We've got F of 3, that's 15. We've got F of 6, that's 3, F prime, and F prime. So we're told nothing about G. Well, remember, again, that G was F inverse, same thing as F inverse. So evaluating G of 3 is the same thing as evaluating F inverse of 3, which is going to equal some X value there. Or in other words, 3 is equal to F of X. So what must X be? What must X be so that when I take F of it, I get 3? 6. F of 6 is 3. So the X value that can go in here, okay, 6. So what is F inverse of 3? It's 6. In other words, what is G of 3? It's 6. So this is 1 over F prime of 6. What's F prime of 6? Negative 2. Negative 2. So this is negative 1/2 is your answer. Okay, sorry, I kind of like scrunched up my work there. Okay. So go ahead and give number 6 a try there. It's a similar scenario that you're given, okay? Except in this case, you're asked to find G prime of 2. That's all. But go ahead and try number 6. See what you can come up with there, okay? Again, dead giveaways that this is that F inverse prime stuff. G is the inverse function of F. What is the value of G prime? In other words, F inverse prime of 2. So I'll go ahead and write this up here. Okay? So go ahead, give that a try. See what you can come up with there about what the answer is going to be. And I'll come around and check.
Luke's perfect, and so is Carter. I said you're really attractive. Zoe looking good. Carter, I'll never call you really old.
So, G of 2 is 1.
Right, I want to say Carter.
1. Because again, it's
Or
1
Carter,
over.
Carter, you're gay. Combine them together.
Actually, good. Yep.
No, actually, it's all.
So, F of what? So F of, there's 2, right? What X
I think that's a good way of going about things, actually. She what? I'll correct it.
Good.
Alright, I'll try B. Yeah, I sat down, I was so close actually. I sat down, I was ready to study. I was like, you know what, I'm going to study for this test.
So, you want to evaluate what is G of 2?
Yes. Wait,
Or what is an inverse of 2?
is this an inverse?
No, that's
I
a
have
problem.
like.
So, here's the thing.
Oh, I see. I'm supposed to switch around the x and y values, but do I see two values for 2. One of them is x and one of them is that's x.
Only have like 3.
Do I?
I'm flipping this around.
I did all like words.
So yeah, f of what gives you 2 there according to the table?
1?
1. So then it'll be 1 over f prime of 1.
I'm really tired. I was like,
So
no,
that's
take a shower.
g prime.
I'm going to study. Take a shower, sit down.
G and 2 is
5 minutes.
My parents will pay up to 5.
Okay, so for number 6, the answer is A. No, it's not B, it's A. Okay? Questions on any of that? Questions on any of that? All right, so if not, your homework is on Google Classroom. Okay? This is the more traditional way that you will see the question being asked. Okay? These right here is probably what you'll see in the book, just because that's the way the book kind of gives them. But these are more AP style right here. Okay, so just so you know. All right, and that's all I got for you today. Yes, you may. You have to go? Can you accompany her so she doesn't fall in? I got you.
So you still don't mind on the paper clip?
I do. You want a certain size paperclip, or is that okay? You're welcome.